I am William Cook, and I am pleased to be here for my first talk at Java 1. I'm a professor at the University of Texas at Austin, and prior to that, I was involved in the first internet software boom. So I have a lot of industrial experience. I was at an enterprise software company called LINQ in the late 90s and early 2000s, and so some of the stuff that I'm going to talk to you about is motivated by that experience. Now, what batches are about is it's a technical innovation that's a new way of doing remote procedure calls, SQL client access, or being a client of a SQL server and web services. And it's one of these things where we have lots of solutions here, and everyone's kind of tired of it. I mean, everyone's worn out, right? We've got Corba and RMI, and all these different SQL interfaces from starting with JDBC onward, and so I could understand everyone being a little blasé and saying, "Well, why should we keep talking about this? There's obviously nothing that can be done. It's just going to be a mess forever." But I think that I've been working on this problem for a long time, and it's kind of embarrassing that I feel like after 10, 15 years, I finally have a good solution. But sometimes simplicity is the result of a lot of hard work and letting go of some of your basic assumptions. So if you just take one of those directions, the remote procedure call, and how it essentially evolved from the idea of a single remote procedure call. Well, we can make a stub that'll send this call remotely and get the result and marshal the answer back. And from that little seed was born all of this notion of distributed objects, right, with RMI and DCOM and Corba. A lot of work has gone into this. And there's a book about how to create these kind of distributed object systems, and he touches on a bunch of other things too, but he talks about the sort of the vision of this remote procedure calls, which is that you can use existing languages. You just take a language and you can make it remotable. It's got what looks like a very elegant object-oriented model, but there are a number of problems. In particular, latency is one big problem, where the more calls you make, the longer it takes, and the cost is essentially linear in the number of calls. So every call is a round trip to the server, and so the more calls you make, the more round trips. And on a cell phone, the round trip time is very long, and so the latency is quite high. It also implies stateful communication because the server is getting multiple individual calls, and it has to remember the object state between one call and the next, and so you get this idea of distributed garbage collection, and it's just, it also tends to be very platform specific because, come on in, just started, because the values that are being copied back and forth between the machines are often serialized. They have their internal structure put on the wire and serialized, and then they need to be read off and dealt with on the other side. And so that assumes that there's some uniformity there. So we've got solutions to some of these problems, like doing remote facades, which means you rewrite your server based on the client's behavior. If the client always makes 3 calls in a row, then you make a call on the server that implements those 3 calls, and you can do it in one round trip. But then what if your client changes and adds a 4th call? You have to rewrite your server interfaces. So it makes it, architecturally, it's very bad because your server design depends on your client behavior. And that's just wrong. So server facade, or the remote facade, is not very good. And the same thing applies to data transfer object. If you want to get 3 pieces of data, you make a data structure that pulls down all 3 pieces at once instead of having to do individual getters. And then again, that's kind of hard coding your client behavior into your server. So I guess my conclusion from all this is that this whole line of work is, we've kind of made it work, but fundamentally it's not used very much. I mean, RMI doesn't get used. Corba, I think this whole idea was fundamentally a disaster. From a programming language point of view, is that it's one of the massive, just kind of construction failures, that the amount of effort that went into making all these technologies hasn't paid off. So what I want to do is just start over and reconsider the problem and make a slight change to our assumptions. And the first assumption I'm going to change is that rather than looking at a single remote procedure call. Let's look at 2 at the same time. Okay, we want to make 2 calls to the server. And so the idea here is that R is a remote object and print is a local function. And so we just want to get the name of R and get the size of R and print out the answer. Okay, under Corba RMI semantics, that takes 2 round trips to the server. You look at it, immediately you go, well, why should we do 2 round trips to the server? What we want to do is do this in 1 round trip. And so you could make a server facade and change your server interface to make a get name and size method, but then you get into this whole, oh, we're just redesigning the server to match the client, which isn't going to scale. So I want 1 round trip. I haven't illustrated a proxy in this example, but I also want to get rid of proxies. Proxies are the stubs that allow you call the proxy on one machine and it forwards the calls to the server. Those are bad because they're stateful. They require the server to hold state on a per client basis. Okay, so stateful doesn't mean that the server has state, or stateless doesn't mean that the server has no state. The point is that the server obviously has state. The question is it maintaining per client state on a connection basis? So we want to get rid of that. Platform independent, meaning it should work across any machine, any language. So you should be able to call from Java to Python, Python to Java. You can't serialize the internal of your Java object and send it to a Python VM and get it to come out, right? It's just inherently not platform independent. And then I want to get rid of all these bad anti-patterns, essentially. My argument in this is that data transfer object is an anti-pattern of the most vicious sort. It's just absolutely wrong. Whenever you think you need to write one, there's something wrong. Same thing with server facade. Same thing with changing your server interfaces to say remotable and things like that. You shouldn't have to rewrite your server. Okay, so how do we do this? Anybody tell me? Just how do I solve that little problem of doing that in 1 round trip? Anybody got an answer? You know, right? You're smiling. No? Well, yeah, Jason, but at a high level, what's that? Well, you need to bring the object down locally. Okay, but let's say it really is a transactional stateful object and we don't want to bring it locally. Okay, it really does exist on the server. And we don't want to copy objects around, let's say. So what if we could send, so what, if you think about what RPC does, it sends a command line to the server. It's like a little script to execute 1 procedure call, right? What if we could make that script have 2 lines and send it to the server so that it said, get the name and called the get name method and the get size method in 1 script, okay? What's going to have to happen there? Well, we're going to need to buffer up the 2 results, right? So we need to get the A result as the first result and get the B result. Then we'll bring back down to the client a pair. And then the client can happily print the first element of the pair and print the second element of the pair. So if you can just sort of take all the server stuff and send it to the server and do it in 1 go and bring the results down and then run all the client code that needs those results, then you'll get a really nice behavior. And that pair is essentially the data transfer object. It's been created for you automatically. And the little script that you sent that said, get the name and keep the result, get the size and keep the result, that's your server facade. It was also created on the fly. So we're doing those anti-patterns in the compiler instead of in the programmer. So here's the solution, is to just introduce a new language construct called batch. And what batch does is it means let's communicate with a remote service and make sure, and we give that remote service a name, R, and we give it its interface, item. And the item interface is essentially the virtual interface of the remote server. It says exactly what capabilities that server has in the sense of a capability model. And we can call get name and get size on R, and then bring the results back and print them both out. And the semantics of the batch is that it always requires exactly 1 round trip and no more. So it's block. The fact that it has a scope matters because it's saying I'm going to do all of these commands in 1 round trip and guaranteed. Okay, so it gives you a performance guarantee in a kind of nice semantic package there. So the way it works under the covers is that the compiler transforms this code to run it in a completely different way. Instead of calling, a remote object and another remote object. It completely rewrites the code to send a script to the server that contains 2 lines, get name and get size, on the root object. And then the server executes those 2 calls, and because the 2 calls have been tagged to say that the client needs the results, it makes a pair of results and brings them back. And then the client runs the local code, namely the 2 print statements. So the execution model is completely different than ordinary Java, which is fine. Okay, so here's what the compiled code looks like. If I were to kind of recompile the code and then kind of re-engineer the bytecode. So it creates this script that says call root.getName, root.getSize, capture the out means capture those outputs into a field named A and a field named B, and then so that creates a script. It executes the script, gets a result forest, which is now going to be a collection of results, like a result set in SQL, and then print out the get of A and the get of B. I guess the first one should be get string, actually. But that's okay. And I'm calling this the batch command pattern. And the idea is that you're used to writing this kind of thing manually, right? This looks like a JDBC call. You make a query, you execute it, you decode the results. But the key thing is, in this model, you never write that code. You never write the batch command pattern yourself. You always write this. And the compiler generates the batch command pattern for you. All right? So this is not human written code. And if you ever find yourself writing this code, you're doing it wrong, because that's an anti-pattern at a human level, at a programmer level. That's my argument. Okay, so let's scale this thing up. Now I want to talk to a mail server with a bunch of messages and put a loop into my script, into my batch. So this is going to say, connect to a mail server for every mail message in the messages on the server. If the size is greater than some limit, then print out the subject and say that it was deleted, and actually delete it, and then otherwise print out the message and the date. Okay, so the idea here is that this is surrounded in a batch, which means that the whole thing has to execute in exactly 1 round trip to the server. So how are we going to do that? It's got loops and conditionals in it. Any ideas? You look like you might have a clue on that one. No? What do you think? Think about what data needs to come back. So the blue code is all the remote code, actually. The data that needs to come back is the size and the subject, the date, and the delete may or may not have a result. We could actually talk about that in a second. The only way to do this in 1 round trip is to send a script to the server that has a loop in it. Okay, so this loop needs to get run on the server. The conditional can get run on the server. And then it will conditionally return the subject and delete the message, or return the subject and the date. Okay, that's what the server can do. It can do all those operations, returning the appropriate data, and it's quite happy. And then the client needs to run the loop again to loop over the result set. It needs to test the condition and needs to know the answer that happened on the server, and then it'll print something out or it'll print something else out. So if you think about this code as taking the code and kind of running it once on the server with all the server parts, and then rerunning the control flow on the client control flow is going to exactly mirror the server control flow. Okay? But it's not going to do any of the server operations. It's just going to consume the results that were created and stored on the server and transferred back to the client. Notice that limit is a local integer, so that actually needs to get sent to the server for the server to be able to do this test. So there's really a kind of a handshake that the client sends the script and the collection of data inputs needed for the server to do its work. The server performs its actions and then collects up all the answers and then sends the results back, and then the client reruns itself to do any remaining computations. And it's always exactly 1 round trip, no matter how many nested loops you have or how many conditionals or anything. Now, you're probably immediately thinking, well, this doesn't always work. What happens if I ask the user a question in the middle of the loop? Do you want to delete this file? Well, that's not a legal batch. You can't write that. That's a syntax error, according to the batch statement. So what you'd have to do in that case is write a batch to get all the names of the files and the sizes, and then go through and ask the user if they want to delete them, and then do another batch to delete them all on the server. So there would still be some, you do need to manage the the interaction with your remote service in a logically consistent way. You can't do a batch that involves both many round trips to the client and the server. You have to kind of logically separate it into these phases, but at least then your program is going to logically represent the structure of the interaction with the server, as I need to get a bunch of things, decide whether to delete them, and then send that off to the server. I'm going to...
Would that be a compile time error or runtime error?
It would be a compile time error. Yeah, exactly. I mean, that's why I said syntax error, but it's a compile time error. It's a compile time error if you write a batch where it doesn't have... Essentially, there's a data flow analysis here, a data dependency. The batch has to only depend on things that exist before the batch statement if those things are inputs to the remote service. Okay? You can't have an input to the remote service that is computed in the body of the batch, because otherwise you get a tangling in the data dependencies. And that's detected statically by the compiler. Okay, so I'm going to skip over this briefly, or run through this really briefly. This is just an example of the actual script that gets sent to the server in this case. And you notice that it's got all the code that was blue, and all the print statements have been removed. And it's outputting the conditional of the Boolean, because the client needs to know that. And it's using an input named X. So it's got a lot of stuff. By the way, I'll just mention now that this is a batch script language. And it's not, so we don't send Java to the server to execute. We send these little scripts that are directly analogous to SQL. It's really taking the SQL execution model and redoing it for RPC. And what you end up with, well, so one amusing thing is that I'm using a subset of JavaScript as the batch script language. So it's analogous to JSON, which is the subset of JavaScript, which is the data language. This is a subset of JavaScript, which is the remote scripting language. And this is completely secure. You can't call constructors. You can't call static methods. You can't call anything that isn't in the root service interface. So it's just as secure as normal RPC. You're not opening up your VM to a remote system. And these scripts are executed potentially under very tight control. So the server has complete control over how to execute them. Here's the remaining client. So this is compiled code. After running the script, it decodes, and this is all the stuff that's left over with the print statements and the client code. And the whole data transfer has been managed for you. It's making this essentially a table of A, B, and C values that tell the client what happened on the server and what control flow to follow and what things to print out. Has everybody got the basic idea? It's like, why didn't we think of this before, right? It's so obvious. Why I kick myself every morning because I've been working on this for so long, and it took me this long to figure it out. And one thing that required me to do that was ingrained, one of the assumptions that it requires you to get rid of, is the idea that you can take a programming language, design it completely, wrap up the spec, make the compiler, and then make it remote. If that's your constraint, that you have to take an existing language and make it remotable, you cannot solve the problem, because you need to change the language semantics to do this. So this requires a change to the Java compiler. I've implemented it in OpenJDK. I'm essentially announcing it today, and you can download it and try it out. Oracle is encouraging me to do this and propose it as a future feature for Java. So I won't say they haven't authorized this as an actual future feature, but they're certainly encouraging its exploration. So summary, the server publishes an interface, just a clean interface, an object-oriented interface that says what the clients can access. And then the server also creates a little engine to run these scripts. You can write one in Java in 2 or 3 days. I mean, it just is a very simple language. And it's essentially a student project. The client can only access them. It's stateless because the batch it can actually generate the batch script can access remote objects, intermediate objects, and perform method calls on them. But when the batch is over, the server can actually free up all those intermediate objects because it knows the scope of the entire interaction with the client. It doesn't need to maintain state across the calls in a batch because they all happen in one round trip on the server. The client needs a new syntax and new semantics. It needs to be changed. But you can do this in any language. And the other thing is that there's no serialization in this model. The only data that flows back and forth are strings, integers, dates, reals, and basically primitive data types, just like in SQL. So it's completely cross-platform. Okay, so here's the actual subset. This is the scripting language. It's got variables, constants, conditionals, for loops, local variables. You can actually have local variables in your script, field access, method call, primitive operations, so you can do comparisons and things, and it actually has lambdas. And these input and output are what allows it to do the bulk data transfer. So if you squint and look at it, it's actually kind of like SQL. And I'm going to get into that a little bit more. But it is a subset of JavaScript. And it's a fun little language that's really well suited to exactly this application. Okay, so let's talk about the SQL angle. Again, we had SQL, and then we created all these clients. And, here, everybody see this? This is the batch script pattern, right? This is simple JDBC. Select some files, execute it, decode the results. That's the batch command pattern I was telling you about. So here's the code written in batches. Okay. It's a lot smaller, and you can read it in 2 seconds, whereas this one, you're like, what's going on here, right? There's metaprogramming going here. We're artificially introducing metaprogramming, where we're manipulating programs as values, namely the script. We've taken half our program and we've turned it into a string, and then we run that, and then we manipulate the result set. Why don't we let the compiler do that for us, right? This is the point. You write this, you get the previous slide for free. And so, in case this is not obvious, when you write that, it actually creates this batch script here for f in root.files if f.size greater than 90, output A as the file name and output B as the result of calling f.size. And that's just another syntax for SQL. Okay, so there's essentially an isomorphism between the batch script language, a subset of it that doesn't do. The batch script language is able to call methods and do series of method calls. If you kind of restrict it a little further, then you get something that's just the query subset of batch script, and that can be translated to SQL efficiently. And so what you end up with this is a really nice guarantee that if the service that you're targeting could be an RPC server, but you could switch it over to be a database server, and the batch script language, the translations will all happen automatically. And the other thing that's nice about it is that you actually get a guarantee that every batch statement in your source program generates a constant number of SQL queries. There's no n+1 queries problem. Okay, so every batch equals constant queries. No matter how many loops you do, you can do 5 nested loops, you can do arbitrary stuff, you'll always get the same number of queries at runtime. And so that's a very hard guarantee that, for example, LINQ doesn't give you. You don't know what your performance is. Okay, so in order to do this, you need to have a rich interface. So the server, as I said, publishes an interface. So what kind of an interface does a database server publish? Because what I'm doing is I'm saying that the interface is going to be published in an object-oriented style. But we know how to do that. You take a database schema, and we know how to turn it into an object-oriented, observational, method getter kind of interface collection. And so your database is a set of many customers and many orders. And a many is this sort of generic collection thing that allows you to count it and get the average and do basic kind of SQL collection style operations encoded as methods. And then the order has got its data fields. Customer has its data fields, and you can represent bidirectional relationships as that. I think it might have. I don't know if it got deleted here. But a customer can have many orders, and an order can belong to the customer, and things like that. So all your standard object relational mapping stuff happens, and it works in this case. And so what's going on is that logically you're operating over what look like in-memory objects, but behind the scenes, the stuff that's on those database objects gets ripped out, turned into a script, and then that script gets turned into a SQL statement, and then the results are decoded back into script format, back into appropriate structure to be presented in the original code. Okay, so let's talk about LINQ. So LINQ is very interesting because it introduces for C# this idea of sort of queries as syntax, right? Where you can actually put a little for each files, put the query and stuff. And so it's doing some of this translation for us, where it's kind of taking expressions in the C# language and promoting them to be abstract expressions, which then get run on SQL. But the thing is, that's funny about it, is that it still uses the batch execution pattern. You still have to execute your query, create an artificial result set, and you have to do that yourself, and then you have to decode the results. So LINQ doesn't go far enough in some ways to getting the true kind of abstraction away from this idea of metaprogramming. And then you can really see that when you try and do a dynamic query in LINQ. If you want to have a search page and you have a field that they can enter optionally or not, and if they type in a name test, a test, then it adds that as a condition to the query. And if you don't type in that test, it doesn't add that as a condition. So here you're actually doing kind of condition munging in LINQ, where you create a collection, a virtual collection, and then if there's a condition, the test is a string field. If they specified one, then we update the matches virtual collection with a where condition that kind of slams in a where clause into that virtual collection. The way LINQ works is that the collections don't actually create the SQL statement and go to the database until you say fetch or toList. But anyway, so then we can do a selection on that and then check the actual results. And it'll do the right thing. It's not too bad, but here's the batch version of this. And the interesting thing is that what's going on here is we have a conditional that says if the test length is 0, that is that they didn't specify a test criteria, or if it matches, then we print the thing out. So this is saying if they didn't have a criteria, or if the criteria they gave matches, then print it out. And the interesting thing about the left side of this conditional is that it doesn't involve any server information. The test value variable is a client-side variable, and so the batch system can actually pull out that part of the conditional and execute it before it runs the batch, and use that as a condition of whether to even insert the condition for the second part. So it's doing kind of staging, where it's saying, here's some part of the condition that only depends on local stuff. So why don't I do that before I send it to the server? I don't need to send the server the rest of this condition. So it's essentially the same as the rule for what do they call it? The conditionals are sort of non-strict. They only evaluate the left side. They don't run what is that called? You don't run the right side of an OR if the left side is true. I don't know. There's some name for that. My mind. It's too early in the morning. Short circuit evaluation. Thank you. Good man. Short circuit evaluation. But here we're doing short circuit evaluation against a remote call. So when we short circuit, we don't even send the rest of the condition to the server. Great. That's what I needed. Okay, so it does involve one round trip, as I said. So if you try and get a remote value, like the subject of a message, ask the user if they want to delete it, and then delete it and write that in one batch, that will be a compile time error, because it requires going to the server, getting the subject, going back to the client, getting the answer, and then going back to the server to delete it. So if you do that kind of tangling, it tells you, no, you can't do that. You have to rewrite your program. And that's connected to the idea that the batch is a guarantee of one round trip. So you have to do it in 2 batch statements, 2 round trips. That's just the way it goes. One of my favorite topics. I always say there's no serialization. And I don't know, some people might kind of cheer inside, but most people go, what? How? No, you can't get away without serialization. That can't be. So what do I do about serialization? Well, let's consider the case. So first of all, I prohibit it in the current version of the system. And again, it's experimental. So if we find out that this isn't going to work, we'll fix it. But I have a solution that I'm proposing, and so we can't send the internal guts of a hash table from one VM to another language VM, right? They just don't represent things internally the same way. But every hash table has an external interface that makes sense potentially on both machines. And so here's not an example of a hash table, but of a set. Let's say we have a set of names, and we want to take that set and send it to the server. Okay, so we have a set of strings called local, and we build up this set of local names that we want to send the mail message to. And then we want to take that local and send it up to a server set of recipients. And then send the message to those people, right? So that involves copying the set from the client to the server. And I've said you can't do that. So what do? What we do is we use the nice feature that we can have factories in the server interface. Right? The server allows you to call, has an interface that says what methods you can call, and one of those methods can be make set. And what that does is it makes a server set. It doesn't make a client set, it makes a server set. But then when you make a set, that set in turn has an interface for things like insert of an add, adding up values to it. So what I'm going to do here is in this batch, make a server set and make that into a local variable, which is going to be a local variable in the script that will run on the server. And then locally iterate over the local addresses, adding all of the values from the local set into the remote set using the remote set add interface. Okay, so we take the remote guy and we actually call his remote method to add each item. This looks like one of these tanglings back and forth, but it turns out that it can be untangled by just, before sending the batch to the server, do this local iteration to gather up all the local values out of the set, put them into that input structure that gets sent to the server. Then the server will create the server set, run the loop again, because we're always seeing these loops are getting, and as it runs, it'll pull out the items out of that bulk data transfer list that was sent to the server, and it'll add them into the server set. And then it's got a server set. So you're essentially playing this trick of kind of getting bulk results back, but in the other direction, where we're sending bulk inputs to the server. Okay, and it turns out that there's no back and forth tangling here, because the local information just needs to be collected. All of the local information gets collected and then sent to the server in one chunk. So what I call this is serialization by public interfaces. So we have, the server has a set interface that's a public interface, and we can put things into it using that interface, and we can get things out of our client value by doing getters essentially, or iterators. And so the net effect is basically the same as serialization, right? On the client, it collects up all the data that it needs to send to the server in a block, sends it to the server, and then writes that into the server object. That's more or less what serialization does. The difference is, rather than doing it on the internal guts of the object, we do it on their public interfaces, and therefore it's cross-platform. It doesn't matter whether this server set is a Python set or a Java set. Just as long as we can create one and call the add method with a string, it will work. So and then the trick is that you don't want to write this little helper code. This is a helper code. These 3 lines are the helper code that copies a local set to a remote set. We don't want to write that everywhere that we need to do it, so we need a way of modularizing that into a reusable kind of library call. And so there's a way to do that, and I'll just mention this. It's a little bit squirrely to talk about this, but let me just mention that well, I don't have a great example handy right now. So the point is that up to now, a batch block contains essentially arbitrary Java code. Okay? It's subject to some constraints. The local code actually can be arbitrary Java code. The remote code has to be restricted. It can only perform method calls and simple Boolean comparisons and loops and things. Okay, so the remote code is restricted, but the local code is not restricted. There is this other assumption that is implicit in what I've been saying, that every method call occurs either on the server or on the client. And it's all on one or it's all on the other. Right? And that makes sense in some ways, right? Because every method body occurs on exactly one machine or the other machine. It doesn't span machines. But this case is a case where if you want to put this into a procedure, into a method, then it in fact has both remote and local operations in it. So that's a method that needs to kind of run on both places. So what a batch method is, this include in batch attribute on a method, says that this is a method that essentially when you run it on the client, it gets inlined into the batch. And it in turn can get partitioned. So the method itself gets split into 2 parts. Half of it gets included in the script that's sent to the server, and the other half is local code that gets run. And I know people are looking at us a little quizzically. It's like, what the heck? You don't need to understand this to get the idea. The point is that if you want to really get true modularity, we need to kind of introduce this complexity of methods that can be partitioned. That's the phrase that I use sometimes, is that remote and local code gets partitioned, split into two pieces. Normally, we chop a batch block into two pieces, the remote part and the local part. Everything's clean. Sometimes you want a method that also gets chopped. And so that's what this is. We can make these choppable methods. And the point is that now I write this reusable send method, and now in my mailer call, I can just say send on the local set and have it go up to the remote set, and all that gunk of copying the values is hidden in the send call. Okay, so I've managed to modularize it and hide it. It's probably the nastiest thing. I mean, it's interesting. I think the batches idea is very simple, but it does, unfortunately, get some complexity in the, especially when you start writing reusable libraries. Exceptions are very interesting. What happens if during the execution of the batch block, an exception is thrown? And there are two cases where that can happen. One is that the script gets sent to the server, and while the server is running the script, an exception is thrown. You call the delete method on a message, and it says, you can't delete that, for whatever reason, your security violation or whatever. What happens is that the default behavior is that the batch gets terminated, and all of the results up until that point are returned to the client, and the exception, an abstract version of the exception, gets returned as well. It's not actually the real Java exception, because again, the client could be Python. And what is it going to do? But it gets a description of the exception, and so as the client runs the code, it's going to process the results, and the minute it tries to access the result that was the thing that caused the exception, it will get the exception too. So the same exception happens in the same place, and everything is cool. And that actually works really nicely. So exceptions do get handled. If the server really, there's no mandate that says how the server executes these scripts. If the server wanted to keep going, that would be part of the server contract. Essentially what's going on here is that the batch script is like a server-specific, domain-specific language. The server could choose to execute the scripts in parallel for all the client knows, right? That's what SQL does, essentially. It reorders the execution, right, with the query plan. So the server could also execute the thing transactionally, that if it got an exception, it would roll back all of the operations that had been performed and send an exception at the very beginning saying, batch failed, right? So you could actually do transactional RPC servers in this style, which is very nice. Batches don't require transactions, but they certainly enable them in a very nice way, even for your RPC servers. Yes?
How are you going to, if everything is being returned as primitive string,
yeah.
How are you flagging that it's an action?
Okay. I'm wrong.
Because normally you have to serialize the object. I know what type of object.
Okay. I need to change my spiel. Primitive strings and these special exception values come back. Yes, there's a third kind of thing. And they just are like little bombs. The minute you try and touch one, boom, you get the exception. And so, the client can catch the exception and keep going, or even handle it in different ways, because it's arbitrary Java code. You can't do exception handling currently in the batch script itself. The server script can't catch an exception and proceed, but the client code can. Finally, there's one really nasty bug that lurks in this, and I'll just tell you about it, which is that if the server execution processes completely, okay, but when the results come back, the client code gets an exception while it's actually consuming the result set. Like it tries to print out all the names of the things that got deleted. If it gets an error in the middle and it fails to process all the deleted things, then you actually have a potential bad situation, because the server has actually done a lot of work, but the client failed to kind of process it all correctly. So clients do need to be very careful with their exception handling, because the work has already happened. All the server work has already happened, right? It's not synchronous, like in a normal RPC. So we already mentioned this. They're not transactional, but you can do transactions if you want to. It doesn't get rid of the issue of partial failure, but it reduces its scope because there are fewer round trips. I find this really interesting that there was this article, a really famous article now, the Note on Distributed Programming by, oh man, the name was just in my head, Waldo. Some people might know this. Anyway, I think this was in the mid-90s. They wrote this beautiful note explaining why RPC was so broken. And then they turned around and implemented RMI and did all the wrong things again. And because we hadn't figured out a way to do this right. And so it's like if you go back and read that note relative to what I've done, it actually tries to address some of those issues. So the other thing is that there's a very strong guarantee and there's a very strong non-guarantee that you have to keep in mind. This is what I was just mentioning. That what's going on is that there's remote and local code that's interleaved in the batch block. What happens with the compiler partitions them into the remote part and the local part. And it runs the remote part first. Then it runs the local part. So what's happening is that the order of execution is actually changing of the logical order of execution of the remote parts relative to the local parts. They're being reordered. It's like an optimizing compiler. That the correctness of that transformation depends on the idea that there's no hidden channel of communication between the remote server and the local. If there was like back information, then that transformation will produce a different answer than if you ran it the normal way. If there isn't any back information channel, then it will be semantics preserving. It'll mean the same thing. So there is this assumption that the remote and the remote really does mean remote. When you're talking to a remote guy, the only effect you can see is the method calls. So those get reordered. However, it would be really bad if the remote and local parts themselves got reordered, because they have a logical flow of control that really matters in their own context. So the guarantee is that batches always run the code in the corrected logical order that you would see if it was run, without batches on the server and on the client. They're consistent with respect to themselves. It's only with respect to each other that the reordering happens. And so here's an example that is a compiler error, even though it looks like a valid batch. What it does is it gets a local A, it calls update A on the remote thing, and then it prints out the answer. And then it gets some local B, calls update B on the remote server, and then tries to print out the answer. Now, if you think about what has to happen in order for this to work, we have to call the blue code in one round trip to the server. Therefore, we need all the inputs to the blue code first. In order to do that, we have to get A and B first to send them to the server. But that implies a reordering of the get B and the first print statement on the client. So the logical order is get A, print, get B, print on the client of the red and green code. That's the order in which it has to run. In order to run this as a batch, you would have to call get A, get B, then call the server script, then print, print. And those orders are not the same, so this is actually another compile time error. There's a simple answer, which is to get these two things, put them in a local variable first, make sure they're strings, and strings don't have any side effects, right? That's one of the reasons why we can treat them as, primitive values are good, and then call the two updates. And then you're fine. Because if get B, for example, gets the length of the print stream, then you're going to get a wrong answer if you run the get B before the print. That's an example of the hidden state. Okay, so I'm going to kind of blaze through this really quickly, but web services are interesting too. We kind of went from HTML to XML and then these web services things, and there's at least two ways to do web services. One is RPC web services, and all of my arguments about RPC web services are covered in the RPC discussion that we've already had. But the document-oriented web services are really interesting. That's when the client sends a big XML document that says, process this, please. And then the server's supposed to do some work and get the answer back. And it turns out that there are examples of this document-oriented web services around, like Amazon Web Service interface to its product catalog. And so what this happens here is that you send a request, you send the item IDs, and then you send the names of the methods you want to call, the properties you want to access on those two item IDs. And when I see this, I immediately think, there's a loop here, and there's two getters. And to write one of these things, and essentially what's going on is this XML document that's being sent is like a custom scripting language. What it means is, for each of these items, get these two properties and give me the answers. Okay? And every single API call, individual call, has a different scripting language with different conventions. Okay, and here's how you call one of these things. You create an object, you create a request, and you put the things in, and you put the other things, and then you execute it, and then you decode the results. Okay, so that's the same anti-pattern happening again. But this is even worse because we're we're doing it in XML, right? Everything's worse in XML. Although I like XML a lot. When you metaprogram directly in it, it's pretty ugly. So here's what it looks like in a batch. You make a connection to the server, you log in, you get the first item. So this is actually asking the remote service for item 1 and getting a virtual remote handle to that remote object called item. And then you display, which is the local method, the sales rank and the small image. But keep in mind that this item A, that's a server object that never gets instantiated on the object. There's never a proxy for that object on the client. It never gets instantiated on the client. What happens is that a script gets sent to the server, which gets that item, and then calls these two, specific methods. Oh, I didn't mention, but besides dates and strings and integers, there's also binary data blocks, like images. Okay, those are essentially primitive values as well, blobs. So exactly like SQL. And then we get item 2, we print out the sales rank and the small image, and you're done. And there's none of this sort of meta stuff. Whenever you're creating a request object manually and populating it with stuff, you're creating syntax. And you're going meta. And you can just see that you have to process this with 2 levels of intention, right? There's the code that's running in the Java that's creating the code that's running on the server. And that indirection, this is analogous to direct manipulation user interfaces, right? You like direct manipulation because you click on the object and you do things to it. This is not clicking on the object and doing things to it. This is writing down a recipe to tell the person who actually is on the other side of the LAN to click on the object and do it. Whereas this is direct manipulation. Yeah.
Got a lot of sort of the same code though, repeated, the only difference between 1 and 2.
You could put loops and things, but it's still not going to get rid of that indirection. And you could wrap this by a nicer call on the client. I'm just saying that the batches kind of do the plumbing for you. So there are ways to clean up the ugly version, but this is kind of a power tool for cleaning it up. We did actually do a version where we wrapped the Amazon Web Services with a batch interface and ran this code, so it does work. Okay, so the hard part, if you're interested, is adding batches to your favorite programming language. I've done it for Java. I have a student who's doing it for JavaScript, another student who's doing it for Python. The server side is actually really easy because it just needs to execute scripts. That's trivial. The client side involves actually this partitioning process, and so that's a compiler activity. What actually happens under the covers is that the source code of the original language gets converted into a script with an other node that represents all the stuff that can't be in the batch script. There's a partitioning algorithm that's written as a library that you can run. It kind of creates the 3 stages, the local part, the remote part, and the local part. The remote is guaranteed to not have any other nodes in it because those are, by definition, things that only can happen in the client. And then that gets rewritten back into the little pattern here, the batch execution pattern, where it calls the local stuff to create the script and the local inputs, executes the remote part, gets the outputs, and then post-processes them. And all you have to do is really write these 2 transformations back and forth. It's done as a completely, you know how they introduced the new for loop into Java, the for in loop essentially. There's a phase in the compiler that translates that into a normal for loop. Batches are done the same way. It's plugged in a very modular way where just it actually uses exactly the same trick. So let me just mention the batch OpenJDK Java C that I've released has no syntax changes and no type checking changes at all to the Java compiler. It's completely, batches are just an optimization. In order to achieve the no syntax changes, I couldn't add the batch keyword because that would break the language and break Eclipse and break everything, right? So instead, what I do is I use the for loop. It turns out that for and batch have exactly the same syntax. It takes an interface, a local variable, a thing to operate on, and then a body. And the rule is that if this implements iterable, then it's a normal iteration for, and if it implements service, then it's a batch for. And what you mean when you say this is for, get me this remote handle to this remote service, do this body one time. It's not a repeated for, it's kind of a declarative for this server connection, do this body. And the semantics of that is completely different, as I said, but the syntax and the type checking and everything else is the same. So there's essentially no language changes at all, except into the fact that this kind of for gets, if it's a batch for, gets rewritten. You can also write your own pluggable service providers, and I have a couple that'll execute things remotely, they'll execute them locally, that'll translate them SQL. So it has a full SQL generation ORM type system with all, including inserts, deletes, and updates in bulk, and aggregates and sorting and stuff. And you can do XML transport, JSON transport. It's easy to add your own transport to transport these bulk record sets back and forth. So this whole fetish about is it XML encoded, is it JSON encoded, is it this encoded, it's just, it doesn't matter. That's irrelevant. Okay, so the idea here is we take the best things out of these three guys. Web services are cross-platform, right? But they're really ugly. RPC is kind of beautiful. You just directly call your methods. And SQL has this whole bulk, transfer thing going on, which is really cool, but doesn't, it's hard to interface with your regular language. And you just unify those three things into one new construct called batches. If anybody has a better name for this, I'd be happy to find a better name. But anyway, so it's it's actually a very general statement for dealing with remoteness. And I even have projects that are thinking about your GPU as a remoteness. Okay, you want to talk to your GPU efficiently, you need to do bulk data transfer and transfer scripts to it. That's exactly what coprocessors do. So you could use this there. It unifies distributed objects and RPC style programming, relational database access, clients, and service invocation for web services. And it gives you all these beautiful benefits. It's efficient because it gives you a performance guarantee. It has a very clean programming model. It's direct manipulation instead of indirect manipulation. And there's no queries. It's stateless. There are no proxies. And it's completely language neutral. So I'm having a lot of fun, other than the fact that it took me so long to get here. And the big nasty thing is that you can't do it as a library. You have to change your compiler. And so that's what I've done for Java. And it's available now to try out. I'd love to have people help me out and work on this. And we're going to turn it into an OpenJDK subproject is the current plan. I think that I'm done. So thank you. Any other questions? We had a few during the talk. Yeah.
Issue of just primitives only.
Yeah.
It strikes me that when you're dealing with, you're typically dealing with objects that you want to access.
Yeah.
So you're doing patiently for customers with addresses, and it seems like we're all going to be writing a lot of the same old marshalling and unmarshalling
Yeah.
that we used to do a lot of.
Yeah.
That things like RMI were created.
You'll actually find that a lot of the marshalling and unmarshalling happens automatically in those collecting up the bulk results. Okay, but you're right. The other kind of big, advantage or disadvantage, depending on how you look at it, of this current proposal is that the server objects only exist on the server. They don't ever exist on the client. So it looks like an object relational mapper, but it doesn't bring the objects down. All right? It just brings down the parts of the object that you need to do the local part. It'll bring them all down. But so that is probably the one area of kind of research open, that whether the current thing is good enough. If you wanted to add sort of that idea I talked about, serialization by public interfaces, that could be automated. Right? You could say, get me this object, call all of its public methods, and then call this local object and write the stuff in, right? Because that's essentially what you want to do, right? You want to the server object doesn't really exist on the client because it could be implemented in a totally different technology. But logically, it does exist on the client. And so a kind of automated copier that would just kind of read out the data and write it back in, I think would be really cool. And we could do that. And then it would, I think, satisfy your concern. But that's absolutely, right now I'm kind of holding the line and saying, can we get away without it? But my guess is we probably won't. And maybe I'll add that. So help me out. Other questions?
Is there a spec for the language that gets generated or script?
The script language, yeah. Right now, the specs are given as a series of academic papers published at UPSLA and ECOOP. But I am converting them into a kind of more normal Java spec format. And so there will be one, yeah, definitely.
What about the asynchronous calls?
Asynchronous calls. Yes, so that's the other thing that's really interesting is most people say, RPC is broken. The answer is asynchrony, right? Now, asynchrony doesn't help if you have conditions, if you have ifs in your loop. So batches actually run faster than asynchronous code if you have conditions, because a condition causes the client to have to block and wait for the results before it can know what next call to issue. By transferring the condition to the server, it actually can run freer. Now, so in that sense, there's some ways that batches can perform better than asynchrony as it's traditionally understood. Now, the other thing is that there's no reason why we couldn't run the batches asynchronously as well. And actually, right now, it's a synchronous thing where it sends to the server, gets the result set, and then brings it all down. But the way SQL works and the way batches could work is that you could actually run the server and the client as coroutines. And the minute the server starts producing results, the client can start running. Okay? And essentially, you'd stream the result set back to the client. And so that would give you full asynchrony, again, without having to write any waits or async calls or anything. So that's another research area, is to make an asynchronous version of batches. Yeah, but I guess it's both. If you look at LINQ, batches kind of use some of the LINQ ideas. It uses filter procs and group by things that are procs. So it uses some of those ideas. Again, with it's completely compatible with asynchrony as far as I can tell. It could do this object serialization thing a little more automatically. So there's a lot of room to build on this basic intuition that we're just going to do multiple things at once instead of sticking to the synchronous model. Okay, other questions? We done? I know you got to get to your next talk. Yes, one more.
Do you have examples of your server side for this?
I do. I have a Java server side. It's like 300 lines of code. I mean, it's just trivial. And I mean, you'd like to make it more robust by doing some maybe if you wanted to add a security model. It's already fairly secure because you can only call public interface methods. But it uses reflection. I have a Python server, and the Java client can call the Python server. And yeah, the thing is that you have to realize that these server interfaces get written down in Java, for example. But when Python uses them, it just uses name matching, right? It doesn't actually have an interface. Yeah. Okay. Cool. Thanks again.